Big day today, people. I think this may be like the only set of notes where it's just single-sided. So this is going to be awesome, short and sweet. Volumes of spheres, one shape we're doing today, wrapping up our volume lessons right now. Now, recall from a few lessons ago that the surface area of a sphere is given by the formula 4 pi r squared. All you needed is the radius. It's the same deal with volume, tells you how much space a sphere takes up. All you need is the radius. The formula is, and it feels kind of random, but it's 4/3 pi r cubed. So all we do is like add a couple threes into this guy and we got our volume. So 4/3 pi times the radius cubed. That tells you how much space a sphere takes up. So let's just do a really straightforward example. Practice typing this into our calculator because that might be new for some of us. Let's say they give me this sphere right here. They tell me the radius. I want to find the volume in terms of pi and rounded to the nearest tenth. So volume is just 4/3 pi. The radius is 6 cubed. Okay, watch, especially if you're like, ooh, I'm not convinced I can type that in my calculator. Here's what you would do. So I do 4/3 with the fraction button. The ABC right there. So I do 4ABC3 times pi times 6. Now, to do something cubed, you do the caret button right there and then raise it to the third power. That just means 6 times 6 times 6. That would be your volume. That would be the rounded answer. Okay, I guess I should have done that second, but here we go. I did it first. So that is the rounded answer. I typed pi into my calculator. So to the nearest tenth, that would be 904.8. I need to get my life together. I tell you guys that. I need to tell myself that. That's how many little 1 by 1 by 1 meter cubes can fit inside this guy. So it's meters cubed. To write this in terms of pi, you don't want to put pi in your calculator. So what I'm going to do is come back up and delete pi. So you just do 4/3 times 6 cubed. That's it. And that'd be 288. Stick the pi back on. I wanted to show you guys how to delete something in your calculator. You press the DEL button. Okay, that's why I did that. Just kidding, I'm an idiot. All right, so that's a really basic example. Use the caret button to do cubed, caret 3. Now, probably won't ask you something super straightforward like that. It maybe would look more like this. This is a composite figure. It's a pill capsule. We saw this problem with surface area. Here it is with volume. Picture of an empty pill capsule. A pharmacist wants to fill the capsule with medicine. How much medicine will fit inside the capsule? So we're not just talking like around this thing anymore. We're talking inside it. How much space is there for medicine to fill? That's volume. So there's two shapes here. This is a composite figure, like I said. Maybe come over here. Maybe if I did that, you could see it a little better. But basically, guys, it's a cylinder in the middle. Maybe you can see that. If you pulled the cylinder out, push the ends together, it would be a full sphere. There's a hemisphere, half a sphere, on either side of the pill there. So I'm going to break this up like I always do when it's composite figures. And I'm just going to do full sphere. You could just find like one hemisphere, double it. I'm just going to think of it as a full sphere. So backtrack to volume of a cylinder. We're talking volume, pi r squared h. Sphere, I know, is what I just learned, 4/3 pi r cubed. So I need the radius and the height. I'm talking about the cylinder. The radius would just be here. So the whole thing is 8.4. 4.2 would be my radius. Now, the height of the cylinder is the piece that connects the circle bases. Maybe you like looking at it like that. But 15.2 is the height of the cylinder. I'm going to wait to plug it into my calculator. I want to round it to the nearest tenth, so I don't need to even bother with like in terms of pi. I'm just going to leave it like that, and I'll multiply in a minute to get the perfect answer. Let's set this guy up. So it's a full sphere. the radius of the sphere would be the same as the cylinder, 4.2. So here's what I'm going to do. I'm just going to take the cylinder plus the sphere in my calculator. So it's going to be kind of long. Bear with me. So pi times 4.2 squared times 15.2. I'm going to add that to 4/3 pi times 4.2 caret 3 raised to the third power. And I should be good to go from there. And I'm good. Nearest tenth would be 0.7 right there. So it is 1152.7. Real world application, that's how much medicine could fit inside. Pharmacists would know, 1152.7 millimeters cubed. Okay, that's kind of how you'll see volume of spheres like thrown in. It'll be thrown in with another figure. On its own, it's just kind of too easy. All you need is the radius and a calculator. You might see it like example 3 here, what we'll wrap up with. This time they tell me the volume of the sphere. I want to find the surface area of the sphere. So think about your goal here. I like to do that first. My goal is to find the surface area of the sphere, which is 4 pi r squared. All I need is the radius, but they didn't tell me the radius. They told me the volume of the sphere. So anytime they tell you what a formula equals, my advice has always been to you guys, write down that formula. It's what we just learned, 4/3 pi r cubed. I know the volume, V, should equal 2304 pi. So let's plug that in there. I can work backwards to solve for the radius, which is what I need to calculate the answer. So watch what I'll do here. First thing I like to take care of is the pi. And I just need to get r by itself. If you divide by pi on both sides, it's gone. Don't have to think too much about it. We all have calculators here. Do not let the fractions scare you. You're multiplying by 4/3, so just divide by 4/3. You could also like multiply by the reciprocal, but like I can go divided by a fraction for ABC3. I would just type it in like that. And it comes out nice. Okay, I'm kind of run out of space here, but it's 1728 equals the radius cubed. Okay, I don't know if you guys would know what to do from here. You've probably seen it a few times in the past in like your math career, not in geometry, but you want to figure out what number cubed equals 1728. So what times itself 3 times is 1728. Normally, if it's like r squared, we'd do the square root. Here, you have to do what's called the cubed root. That cancels out, cubed. Don't do the square root. That says what times itself twice. You want what times itself 3 times. So that's cubed root. You've got to plug that into your calculator. Okay, I'll probably like note it on here because you might want that on your notes, but to do cubed root, do you see above caret, it's like a square root with an X out front? You have to press second, that button. No, you don't. Press 3 first and then press second, that button. Here we go. I need to get my life together. Okay, backtrack. Press 3 first. Then you press second caret, because that X means like you can put any number out front that you want. Normal square root is exactly that. It's a square root, but you can have cubed roots and 4th roots and 5th roots. Algebra 2 coming in hot. So I want to tell it, hey, cubed root. So 3, and then press second caret. Then you type in the number underneath the radical. So it's going to equal 12. That's my radius, which is what I'm going to take right there. I'm going to make a note here. To type this into your calculator, you do 3, then second, caret. Then you typed the number. I don't know. If you feel like that'll be helpful for you to have in your notes, write it down. But 3 for the cubed, and then second caret to get that radical, then the number that you want the cube root of. Okay. I want my answer in terms of pi, so I'm going to take the 12 here, Do 4 pi 12 squared, leave pi out because you want your answer in terms of pi. So the square root would be 576 pi. No units, so units, and it's surface area, so it's units squared. All right, that's it.